My name is Nicola Murphy, and I'm here today to talk about the design and preparation of porous PLA scaffolds and the effects of degradation. The production of polymer scaffolds faces many obstacles. The current best method is fused deposition modelling, but this still has its limitations, such as cost-effective mass production and the accuracy of the print. There are certain parameters to be set during the printing process, such as layer thickness or infill density, which can affect the quality and the mechanical behavior of the printed part. The scaffold is made of polylactic acid, or PLA, which is a thermoplastic polymer. It was designed in Autodesk Fusion using a single solid cylinder and then rectangular patterns and copied layers. It was 3D printed in PLA using fusion deposition technology using the Ultimaker 3.0. The uniaxial compression testing was carried out in a Zwick biaxial tester for both the PLA log pile scaffold and the control solid PLA scaffold. Both of these scaffolds were then put through accelerated degradation conditions, and the pore diameter and strut diameter were measured before and after degradation. The compressive moduli seen on the first graph shows that there is a statistically significant difference between the solid scaffold and the log pile, with the log pile having a much lower compressive modulus. You can see that after 3 days of the degradation testing, there is no statistical difference between the loss of mass in the scaffolds, but after 7 days, you can see that the solid scaffold has lost more mass. When comparing the pre and post degradation of the mean pore diameter, it can be seen that the mean pore diameter is larger following degradation, and the mean strut diameter then is smaller following degradation. Using theoretical values and calculations, a compressive modulus of 0.14 gigapascals was found for the log pile scaffold, and using our test data, a value of 0.16 gigapascals was found. The compressive modulus of human trabecular bone has been stated to be 0.15 gigapascals. Therefore, based on mechanical properties, the PLA log pile would be suitable for use in bone tissue engineering. The log pile scaffold has a lower degradation rate than the solid scaffold, which allows new tissue to replace the scaffold as it degrades. In conclusion, while the material and manufacturing technique gave the expected results, there are some limitations to the findings. The testing was not completed on the performance of the mechanical properties of the scaffold during the degradation time period, and sufficient data points do not exist for the accurate calculation of the loss of mass.